right, the last problem. What mass of solid nickel is expected to plate at the cathode if a current of 1.10, I'm going to write amps here, you might see that later, was applied to the battery above for 3 minutes. So we're starting with 3 minutes. That is not a conversion factor. But we do know a couple factors involved here, and I'm just going to list those out. We know that 1.10 coulombs are present in every 1 second. That's the same thing as saying 1.0 amps. We know that there are 2 moles of electrons needed for every 1 mole of Ni reduced. Okay, we got that from the half reaction right here. Boom. 2 moles of electrons per every 1 mole of Ni that is reduced at the cathode. We know that there's 96,500 coulombs per every 1 mole of electrons. That is Faraday's constant. And we also know the molar mass of Ni, which is 58.6 grams per every 1 mole of Ni. So let's do the problem. We obviously have seconds floating around in here, so we got to convert the minutes to seconds. 3 minutes. For every 1 minute, there's 60 seconds. Okay, seconds is going to have to go on the bottom, and the only other thing with seconds is my current. 1 second, 1.10 coulombs. Use that factor. The only thing that can go on the bottom is coulombs, and the only other unit that has coulombs in it is Faraday's constant. 96,500 coulombs for every 1 mole of electrons. So moles of electrons is going to have to go on the bottom here. The only other thing that has moles of electrons is that factor. 2 moles of electrons per every 1 mole of nickel. So obviously moles of nickel are going to have to go on the bottom. The only other thing that has moles of nickel is the molar mass. For every 1 mole of nickel, there's 58.6 grams of nickel. There it is. The mass of nickel ends up being 0.0602 grams of nickel. All right, guys. So after looking at this, I encourage you to download this document, redo the test if you like, download the multiple choice, watch that vodcast, and you should be fine. Take care.